Morning.
Hello. If you haven't already, we're going to be doing 2.8 today. So go ahead and get that opened up. All right. Like I said, we're going to be doing 2.8 today. So we will be finishing up Unit 2 this week. We have 2.8, 2.9, 210 left to do. And then our Unit 2 test will be on Friday. You have 2 quizzes this week that are both on Schoology that, again, they're short, they're multiple choice. I believe both of those are multiple choice as well, completely. And so they're just going to give you a way to really self-assess and see where you stand as far as the material that we're doing. So that before you get to the Unit 2 test on Friday, you know what you need to focus on to review for that test. Okay, so we'll have a quiz today over 2.6 to 2.8. Let's do tomorrow. And then we'll have one Wednesday that's over 2.9, 2.10 that's due on Thursday. Okay, review will be Thursday, test will be Friday, and then we'll go from there. Test will be the same way this week. It'll be through Schoology. I believe the whole thing is going to be on Schoology, just like it was last time, where some of the questions are same multiple choice, and other questions are fill in the blank that you're doing it directly on Schoology. Okay. Any questions before we get started here?
Are we going to be using a stylus on the test to show our work?
Yes. Just like the first test. The
Okay.
Unit 1 test. Yep. All right, we're going to start out a little different today. You do have a quiz today over 2.6 and 2.7 and 2.8. 2.6 and 2.7 is where we really started with our factoring. We started looking at our different types of factoring that we could do. First, we just talked about factoring quadratics using the X method. Then we talked about sum and difference of cubes. And then today we're going to talk about this way of factoring by grouping. So it's just a new way to factor, a new way to break down a polynomial into multiple things that can be multiplied together, right? So it's just a new method. And so before we get into that, we need to be able to kind of refresh and know how to do the types of factoring that we've already done. All right, so if you have the notes opened up, we're going to start off with a little warm-up today. Just kind of get a little refresher on what we've done in 2.6 and 2.7. So if you can see my 2.8 notes here, I want us to start by factoring these 3 examples here. So go ahead and do that. All right, let's take a look. So like I said, we're just looking at a new type of factoring today. And so I wanted to refresh and make sure that we know what we're doing with this type of factoring before we move on. So remember with factoring quadratics here, we use our x. So we have a times c here, so that's going to give me negative 60. We have b here, so that's my negative 7. We put a on bottom, put a on bottom. Then we're saying what plus what gives me negative 7. And those same two numbers need to multiply into negative 60. So we should get 12 and 5. So negative 12, positive 5, negative 12, positive 5. So we put those numbers here, negative 12, positive 5. 5/3 can't be simplified. X goes in the denominator. This can be simplified. So that's going to give me negative 4 over 1x. So my final answer here is going to be x minus 4, 3x plus 5. Again, if we wanted to, we should be able to easily check our work by distributing here, because we would get 3x squared plus 5x minus 12x minus 20. When I combine these middle terms, I get 3x squared minus 7x minus 20. So I can easily and quickly distribute there, make sure that it distributes out to the original problem that I had. There's my final factored form. Questions? Second one, we can do the same thing. A times C. B, our middle term is not there, so it's 0. Over 9, over 9. So I need two numbers that multiply into 9 and add into 0. So I did that wrong, negative 9. So we should have positive 3, negative 3. So this simplifies to 1/3. This simplifies to negative 1/3. So our final answer should be 3x plus 1, 3x minus 1. You should notice on these type of problems, this is a special case. It's called difference. So subtraction of squares. So anytime this is a perfect square and this is a perfect square and it's subtraction, you're always going to get this where everything looks the same, but your signs are different. Okay, because what needs to happen is everything needs to be the same so that the middle terms cancel out. So that's how your b value becomes at 0 and they cancel out there. Questions there? Last one is our difference of cubes. Okay, remember this is our difference of cubes. So we're subtracting two perfect cubes. So we talked a lot about how this needs to be something cubed minus something cubed. So here it would be x minus 2 cubed. So my a is x, my b is 2. And this is where we factor it into a, b, a squared, ab, b squared. And then this is where we use our SOAP. Same sign, opposite sign, always positive. So it should factor into x, 2, x squared. A times b is 2 times x. And then b squared, 2 squared is 4. And then put our signs in. Same as the original, opposite of the original, always positive. There's my factored form. Questions? All right, let's look at the new type of factoring we're going to look at today. So we have using the X method, right, to factor our quadratics, whether it's 3 terms or if it's 2 terms. We have sum and difference of cubes, and then today we have something called factoring by grouping. Okay, factor by grouping. So when we do this, we use this when we have 4 terms. Okay, so we're going to be using this when our polynomial has 4 terms. All the time. It's always going to have 4 terms. That's when we're going to use grouping. Because then we can separate our 4 terms and we can group them into 2 sets of 2 terms. Okay? So the blue up here says always pull out GCF first if there is one for all 4 terms. That still hasn't changed. No matter what, anytime you're factoring, GCF first if possible. Okay, that still doesn't change in this grouping here. All right, so nothing's different there. If you can pull out a GCF, do that first. From there, we have this kind of this format here: A times B plus A times C plus D times B plus D times C. Just kind of a little format to show you what's going on. So what we're going to do, we're going to take the first 2 terms and group them together using parentheses. And we're going to take this 3rd and 4th terms and group them together using parentheses. Then what we're going to do is we're going to pull out a GCF out of each grouping. So this grouping here, AB plus AC, they both have A in them. So we'll pull out that GCF A, put it out front. Same thing over here. This grouping, both of them have D in them. So we'll pull that out front, like we have here. Then when we look at this, now we have this BC here, and we have this B plus C here. And so what we can do is we can pull a GCF of B plus C out of both of these, and then write what we have left. So then we have this A plus D left. Okay? So it says the yellow part is the combination of the GCFs when you split into 2 groups. D can be positive or negative number depending on the GCF. Green part here must be the same binomial to combine and only bring down the binomial once. I'm picking out very specific problems for you guys to do this on. Okay? Yes, I totally agree. It's not always going to work where this green part here is the same. If that's true, you can't factor by grouping. So if I'm asking you to factor by grouping, I've picked out problems that green part there is going to be the same. Okay, it just works out that way. Again, if it's not the same, you just can't use grouping. We'd have to use some other method. We're going to talk about something called, well, we talked about synthetic division. We're going to talk about using synthetic division to factor. So if it can't be grouped, we have to find some other way. But for now, those should be the same. That's the whole point of doing it this way. Okay? Let's look at an example here. All right. So first thing we look for, GCF. Is there a GCF here? And the whole thing, all 4 terms, do they have a GCF? No. First of all, they don't all have a number. Second of all, they don't all have an X. So I immediately know there's no GCF here because they all don't have the same thing. So no GCF for the whole thing. So first thing we do here, group with your parentheses the first 2 terms. Group with parentheses the last 2 terms. Okay, so we're grouping them together. From there, step 2 says factor the GCF from each group. So now I'm going to go to each set of parentheses and pull the GCF out just from that grouping. So my first grouping here, they both don't have a number, so I don't worry about that, but they do both have x squared. So I'm going to take, and I'm going to pull out an x squared and write what's left. So I have x minus 6 left. Plus, I'm going to do the exact same thing here. So 10 goes into both of them, so I'm going to pull that GCF of 10 out front. Leaves me with x minus 6. Just like I told you, these two right here should be identical. If they're not identical, A, you did it wrong, or B, it can't be factored this way. It can't be factored using grouping. Okay, one of the two things. Usually, if I'm telling you to factor by grouping and they're not the same, I would go back and retry it. All right, so it says step 3 here. There should be a set of matching factors, factor them from the GCFs. So now what we're doing is we're saying, okay, both of these have this factor in them. So I'm going to take that now, put it out front one time, and then write what's left. So what I have left when I pull an x minus 6 out of this is x squared. What I have left when I pull an x minus 6 out of this is just x, or sorry, just 10. So this is where I'm going to get my x squared plus 10. So that's what I'm going to write here. X squared plus 10. That's my answer. Okay, that's our original problem factored out. Now, step 4 says check. So just like always, we can make sure this is right by distributing. So x times x squared is x cubed. X times 10 is 10x. Negative 6 times x squared is negative 6x squared. And negative 6 times 10 is negative 60. If I just change the order of that, x cubed minus 6x squared plus 10x minus 60. That's my original problem. Okay, it should go backwards. It should multiply out right back into our original problem. Questions? I think the biggest mistake that I see on these type of problems is going from here to here. People try to write x minus 6 two different times. Because they see x minus 6 twice right here, they think that x minus 6 needs to be twice down here. But all it is I'm saying x minus 6 is in both of these, so I'm pulling it out front. Exact same thing from going from here to here. I'm saying both of these have x squared. I'm just going to pull it out and put it out front one time. Okay, so that's probably the biggest mistake I see is going from here to here. People don't know how to go from 2x minus 6 to just 1. All right, let's look at the next example. All right, let's try this first one together. So first step, is there a GCF here for the whole thing? No. 4, 3, 8, and 6. There's no number that goes into all those. 6 doesn't have an x, so I'm good there. So first thing I'm going to do, group. Now, here's a very important thing. If this is subtraction, whereas this was addition, this is very important, so listen. If this is subtraction right here, you need to group that subtraction with that, and then just make this a little addition in here. So really what you're going to do is you're going to change this from being subtraction to adding a negative. Okay, so if it is subtraction there, that subtraction needs to go inside of the parenthesis because it's going to change what we factor out. Okay, pull a GCF out of the first grouping. So that's going to be x squared. Leaves me with 4x plus 3. Now here's where that important piece is. When I factor a GCF out of here, my GCF is going to be negative. Okay? So when I pull something out of here, I'm pulling a negative 2 out, not a positive 2. So my GCF here is negative 2, which is going to make this positive 4x plus 3. We want those to match, so that's good. Okay, so now again, both of these have this matching factor here, 4x plus 3, 4x plus 3. So I'm going to pull that out, put it out front, and write what is left when I take that out of both of them. Well, when I do that, what is left? X squared minus 2. So right here, x squared minus 2. Questions? All right, let's do number 2 together. Actually, no. I want you to try number 2 on your own first, and then we'll go over it. Everybody try number 2 on your own first. Yes, Zach. Zach, do you have a question?
I didn't have my hand raised. I was actually typing it. Ask, is the order of the 2 final terms matter in delta math?
It does not.
Okay, so no. It's smart enough to know that.
Yeah, I think it is. That's not one thing I've tried. I will try on delta math just to make sure, but I've tried other answers where I type them in different orders and it knows that it's still the right answer. So I would assume it can detect that as well. Let's go about a minute longer and then we're going to go over it. All right, let's take a look here. So first thing we look for is our GCF. If I look at the numbers, 2 and 3, there's no number that goes into both those, so I'm good there. There's no x in 27, so there's no GCF. So first thing I'm going to do, group the first two, group the last two, put the negative with it. Make sure you put that negative in the second group. If you didn't, it messes it up. Okay, factor an x squared out of the first group. Leaves me 2x minus 3. I'm going to factor a negative because I don't want this negative to be my leading coefficient here. So I'm going to factor a negative 9 out of the second group, which is also going to leave me 2x minus 3. I should notice both of these have 2x minus 3. So I'm going to pull that out front. And it leaves me with x squared minus 9. Now, did anybody go further from there? Can I factor this? X squared minus 9. I didn't have it there. Isn't x squared a perfect square and 9 a perfect square? I can actually factor this. Okay, if I wanted to do it using this, I would say negative 9, 0, which would be positive 3, negative 3. So this actually, we have to go a little bit further with this problem because this continues to factor. So anytime I get a linear like this, I'm done. Okay, unless there was a GCF there that we missed, I'm done there. But if you get a quadratic like this, it might be able to be factored further. The reason we couldn't factor this one further is because 2 is not a perfect square. But if you get perfect squares here, like x squared and 9, and it's subtraction, you can go a little further. And so this actually factors into x plus 3, x minus 3. And now I'm done. Okay, and we hadn't talked about that, going a little bit further like that. I really wanted you to get to this point here so then we could talk about that next step. Okay, so if you do get that answer, you do have to look and see, do I have a quadratic? If they're both perfect squares, you got to go a little bit further. Okay? Questions with that? Number 2. All right, let's look at number 3. All right, number 3. Can I pull out a GCF? They're all even, right? That's really the first thing I look for when I look for GCFs. I say, are they all even? If they're all even, 2 goes into them. And so I immediately know there's a GCF. Now, you might have to look and see sometimes, is there something bigger than 2 that goes into them? But you should automatically know as soon as you see that they're all even numbers that 2 goes into them. Okay, so we can pull out a GCF of 2 here. So that gives me 10x cubed minus 25x squared plus 4x minus 10. Now, what makes this problem a little bit harder is the number of parentheses. Because now I need to put parentheses with my parentheses. And so it gets a little bit confusing or weird. One thing that might help is instead of using these parentheses here, sometimes I will use brackets here instead. So you'll see me use a bracket here and here instead. Because then when I group this, I can use parentheses here and here to split that up. So that's what gets a little confusing when we have to pull a GCF out. Sometimes I'll tell people, just think about the problem, just work the problem out without that 2 out front, but make sure you put it back in at the end. Okay, so if you don't make sure and put that 2 back in at the end, then you're going to miss part of the problem. Okay, but sometimes it's easier to work it out when you don't have that 2 sitting out front the whole time. But now we're going to do it the same way. So we're going to look at this first grouping, pull out a GCF. So we should have 5x squared, which leaves me with 2x minus 5 plus, looks like 2, which leaves me 2x minus 5. And so this is what I'm talking about. I need to bring this 2 down here. So if you want to bring that down, put these brackets around here and then put the 2 out front. Or if you just work this problem out and remember you have to keep bringing this 2 down with it, that's okay too. Just make sure you bring the 2 down. Okay, so both of these have this 2x minus 5 in them. So I'm going to pull that out front, which leaves me with 5x squared plus 2. And this is what I'm saying. Make sure you bring that 2 down. This is a linear. 2x minus 5 is a linear. I know I can't factor it. 5x squared plus 2. The only time you can factor 2 terms is if they're perfect squares and it's subtraction. Well, 5 is not a perfect square. 2 is not a perfect square. It's addition, so I know I'm done. So there's my final answer. Go ahead and try number 4, and then we'll be done. Everybody do number 4. All right, let's take a look. So, first thing here, when you're grouping, make sure the subtraction goes to the second group. Two things here. We've talked about this before. My GCF was 4x squared here. When you pull 4x squared out of 4x squared, it leaves you with that minus 1. Don't forget to put that 1 there. Some people think, okay, GCF's 4x squared, that's gone. There's nothing there. You have to put that minus 1. Second thing, we need to pull out that negative 1 here. Make sure you put that 1 there so that you see that it's left over when you pull it down here. Okay? And then finally, once I get here, we can go a little bit further. I obviously can't factor 3x minus 1 because it's a linear. I can factor 4x squared minus 1 because 4 is a perfect square and 1's a perfect square. So if you're using your x method, we get this. 4 in the a's in the bottom. So that's plus 2 and minus 2, which simplifies to 1/2 and negative 1/2. So when I factor this, it's going to be 3x minus 1 still. And this is going to factor into 2x plus 1, 2x minus 1. And so that is my final answer. Any questions? Guys, this factoring unit is going to be huge for you in the rest of this class. All right, it's to be honest with you, we made it its own unit because we use it so much the rest of the class. The rest of this quarter, and then also second semester, when you take second semester Algebra 2 Trig, we do it a ton then too as well. Okay, so you have to know how to factor. It's super, super, super important. Whether you use the X method, we're using guess and check, whether you're doing sum and difference of cubes, whether we're now doing grouping. Okay, we do a lot of factoring, and it doesn't end in this unit. We use it unit 3, we use it unit 4. I think we use it unit 5. I think we use it unit 6, and then maybe that's it. But we use it a lot even after this unit when we're just talking about factoring. So make sure you're understanding this. If you're not, make sure you're asking questions on what you're not understanding. Questions? All right. Your homework again tonight is in Delta Math. Okay, so tonight it's in Delta Math. 2.9, 2.10 will not be. They didn't have the questions in Delta Math. But 2.8 homework is in Delta Math tonight. And then your Schoology, you have 2.6 to 2.8 quiz. Okay, so due tomorrow is Delta Math and your 2.6 and 2.8 quiz. All right, you guys are good to go work. If you have questions, let me know.
Can you hear me?
Yes, I can now.
Can you see me? I'm so sorry. I'm having connection problems. Okay. Do you have questions for the teacher? Okay. Go ahead. Ask your question. A question about number 2 and 4.
Okay.
Can you explain?
Which piece are you struggling with? Are you okay with the grouping at the beginning?
Uh-huh.
How about, so are you okay with getting from step 2 to step 3? Okay. So the main difference
Step
then,
4.
okay, we're taking this x squared minus 9 and breaking it up into 2 different pieces. We're factoring it further.
Okay.
And then 4, is that what it was? Same thing. Same thing. We're taking this piece, 4x squared minus 1, and breaking it up into 2 factors from there. Okay.
Bye.
That's you.
Sorry again. Thank you, guys.
No problem.